This is Ed Robinson of Kensington College, continuing our lessons on C#. We're talking today about generics. Well, a generic method. Now there is a generic method. A generic method has basically got angle brackets and this variable in here and correspondingly here. So that is a generic method or a generic function. It has two features. It allows us to pass different types, and it's also type safe. That is to say, it can only pass a certain type and not a mixture of types. So let's get straight down to it and see how it works. What I'll do, here's my generic method, and here we are calling the method using an integer, and here we're calling it using a string. Let me single step this and make a breakpoint, and I'll single step it down to here, and let's see what happens when I press F11. It jumps into my method and it passes the value of 2, which is of type int. So the T represents int, because you could consider that the int here has been passed to this T variable. T could be anything, could be UV, which it sometimes is, but the actual int, because of these angle brackets here, has passed its value to here, so that we know that this variable here, T here, is an int. So we're talking about an int x. Well, you can hold it there and you can see that that is the value of 2, and then write the value out, and then we try passing a string. If I now pass that, you'll notice that x has now got the value of ed, which was the string which was passed. So once again, the string is actually passed to T. Well, we can pass a value from here to here, so why not pass a type from here to here as well? Well, we wouldn't want to go using ordinary parentheses, apart from the fact that it'll kick up an error, but that really is what we are doing in principle. We're passing this int is being passed to here as well, but we need to use alternative notation to distinguish, so we can use these angle brackets. So that's what a generic method is. A generic method has got angle brackets. Indeed, we could actually remove the specification here of the int and string, and now C# knows implicitly what this type is. Clever. So you can see that that still works and gives the value of an integer and a string. What would the alternative be to using generics? Well, we would use overloaded functions, but the problem is we have to have 2 of them. So let me just make this an overloaded. I'll use an int type in here to specify, and then if I need to have another function, a separate function to handle the string. Now that should work perfectly well. So I could actually single step that to, I'll put a breakpoint in here and run it to there. Now you'll notice that it's, I'll perhaps put my breakpoint up here. And you'll notice that when there's an integer being passed, it knows very well to use this overloaded. So I'll just F11 to see that it has indeed called this and passed the value of 2 onto this. Now it goes to this one, and the overloaded version, it calls the string version as well. But we do need two methods here, 2 separate overloaded functions. So let me just get rid of those. need to stop my program here, and I'll delete the second function and go back and put in my generic function. Angle bracket here, and instead of this type I use T to represent either a string or an integer. Now we may have seen an array list, which is a collection. There is a problem. Well, what is an array list? An array list is one up from an array because it's more easily expandable. You can add elements, whereas an ordinary array is a fixed length, which is quite a handicap. But so an array list is one up on that, where you can add elements, you can actually remove them, insert them, and the way you print them out is much the same as with an array. So if I just run that to show you that it's working just fine. But you might have noticed that we're actually adding different types here. We're adding an integer and then a double, say, and then a string as well, have been all added to our array. Now you might think that's pretty good and that's very versatile, but it leads to errors. So if we want to reduce our errors, we have to consider something which is generic, which will only accept an integer, only accept a double, or only accept a string. So let's convert our array list, non-generic, into a list, which seems to be a very popular way of dealing with arrays and elements. When we're trying to have a collection of elements, it seems to be quite popular, if you like, to use a list rather than an array or an array list. And we're going to have to make our collections generic, and we're going to indicate the type that we're going to be using for our list as well, and we'll make that there. So you need to remember how to do that so that our array will only accept, our list will only accept integers. So now we have a generic list. But you'll notice here we've got a problem. It won't now allow you to insert the 2.1 or the string. So if we are going to populate it with 3 elements, this in our case needs to be an integer. So you see that our list will only accept integers, or only accept doubles, or only accept strings, depending on what we specify here. So this is indeed very type safe. This is the concept of type safe, that this list will only accept integers in this case, and as you saw, if you try and put something else in, it kicks up an error. Now you might think, that's not really what you want, but you must remember that programming is not about necessarily making things work. It's about working out what to do when the program doesn't work. And so by restricting this, you'll be able to find your errors more easily. When we're printing our list out, the list now is what we call implements IEnumerable, which means we can basically use a for each. So we specify the type. You can have any variable name you like in here, which corresponds to the one here. So you're iterating for each in the list. So when we run that, which is quite a convenient way of iterating over things, over your list, so you'll see once again that the elements have been printed out. What if we wanted our list to hold some user-defined types? For example, if we have a class, we wanted a class called student with 2 properties, and we wanted our list to be able to hold these objects of these type. Well, first of all, our list is going to be holding student type, so we need therefore to specify that type that it's going to hold. So we need to create some of these objects, which we can do in the classical way. Create a new S1, and then I noticed that it's complaining about here that it says it's inaccessible due to protection levels, so I've actually forgotten to make these public. Now that's rather an old-fashioned way of initializing our properties, so let me use the more up-to-date object initializers, which uses curly braces, and so we just need to specify the ID. For example, ID is 1 and the name is whatever. So that's a more modern way of initializing our objects, and now we can have a couple of objects here. And we want to add these objects to our list. Since we've got a list of students, it's probably a good idea to name our list. Instead of LST, we could have students, a list of students, which makes sense. Indeed, we might want to condense all of that. Instead of individually doing that, so we could have our other student initialized as well. And we could iterate over them. Might as well use S there to indicate students, and we need to write out a particular property if we wish. You can see they come up with IntelliSense. So if you run that, and we build that first, and we can run it, and that should print out the first, both their number, their ID and name. Another interesting generic collection is the dictionary. Our dictionary should be holding string values to, in our case, so it's usually 2 types. It could be string and integer, for example, but we'll consider using 2 strings. going to use my dictionary to hold some encrypting codes of the famous Lorentz machine, actually. So there are two ways that we could initialize our dictionary. One way is this indicates the key, and this is actually the value. So the dictionary consists of pairs of items, a key and a value, and the key is used to set and access the dictionary values. There is another way we can initialize. We could use the add and we could so this is just an alternative way of initializing our elements. So we could do this for all the letters of the alphabet. I will just do 3 for the moment. So if we wish to write them out to the console, we could use this notation. We need to remember to use the square brackets. And we might as well write the others out as well. And when we run that, it should print out the actual values. So they've been accessed using the key. Now people usually ask, is there a way that we could access from the value, put the value in there somehow or other? But no, there's actually no way of doing that directly. It's using the key that it's a one-way operation. But how about writing them out? There is another way of writing these out, and that's using what we call the key-value pair. So we define a variable, and we therefore, using that, we can use our for each construction. So that we can access the individual key and the value using the key value pair type. So when we run that, it should print out not only the key but the value as well. Well, is there a way of accessing the value to find the key? So putting in the value of 1011 and giving us the value of B. Is there a way of doing that? Well, at the moment we can only do it using a loop. So let's try and use this loop here and use an if statement. So if the key value pair value is equal to, for example, the second one, then we can write out our key value pair key, sorry. So if we were to run that, it should give us the value corresponding, should give us the key corresponding to that which is B. Now that sounds like a bit of a to-do, and it is. Is there a simpler way of doing that? Is it possible not to use a loop? Yes, there is, and that would be using LINQ, L-I-N-Q, which we'll talk about later. LINQ is a one-liner, so we can actually replace this search with one line of code, and that's the beauty of LINQ, which we'll talk about later.